With me tonight, I have the founder and creator and number one salesman for Smart Denture Conversions, Dr. Brandon Kofford, a great friend of mine and constantly keeping me on my toes with new and exciting products. So Dr. Kofford is going to be doing a little bit of product demonstration with Smart Denture Conversions and walking us through the system in a little bit. And we also have tonight a special guest, Dr. John Bender, who has some very, very exciting research that he's done as part of his master's that involves smart dentures as well. So we're going to get into that in just a little bit. So first off, I'm going to share a presentation with you. It's going to be a brief presentation just about some of the ins and outs of the system and how, from a full arch lab practitioner, we'll say, Smart Dentures has really made my journey in full arch a lot easier. So to start off, here's the obligatory family photo. So my wife, my two kids. I am a 20-year veteran of the lab industry. So my dad actually started the laboratory in 1972. So I'm a second generation dental person. For all of you out there who have family that are dentists or dental lab technicians, I feel your pain. So we were our own laboratory up until 2016, and with the way of the world, we also were acquired by a burgeoning lab group at that point in time. So we were an independent lab, and now I am part of, like I said, the Lexier Lab Group, which is 7 locations up and down the Eastern Seaboard. On top of my day-to-day lab work, I'm also a member of the College of Prosthodontists, much to Dr. Brandon Kofford's chagrin. And I'm a mentor speaker for several implant companies. And I also serve on the board of Dental Lifeline, which is donated dental services. And if you haven't heard of donated dental services, it is a great organization. My 2-second pitch is we would ask you to think about donating your time to serving one underserved patient in your community. If you need any information, feel free to reach out to me on that one. So the Lexier Dental Group, just very, very briefly, founded in 2014, and it is basically a collection of well-known laboratories up and down the Eastern Seaboard. So we have what was Precision Craft Dental Lab in Rhode Island, York Dental Lab in Connecticut, Thompson Suburban Dental Lab in Maryland, Knight Dental Lab in Florida, Blue Box Dental Lab in Mississippi, and we have 2 new laboratories as well. We have a New York location and a second Florida location coming in the very, very near future. So with that, we have a lot bigger footprint now, which is great. We are also the second largest digital design center in the world. We've created that in our back office, which is housed in India. And then we really are focusing on fully digital workflows for implants, for full arch, for general dentistry. You know, that is one of our prime tenets. And we have a large and growing team of sales reps, as well as what we call our surgical advocates that are out in the field to assist with any manner of chairside support that you may have. So I want to start off today talking briefly about a few simple tenets that I hold when it comes to treatment philosophy. And I carry this around with me whenever I'm doing anything, whether it be crown and bridge, removables, implants, or today full arch. And they're very simple, but they've served me well over the past years. And I've created these through a lot of trial and error and a lot of, introspective looking back at cases that failed. And the first and foremost is patient-specific treatment, always. I am not one for cookie-cutter treatments that we blanket on top of our patient population. Too often, I find that people go to a webinar and learn about the latest and greatest technique that's out there and decide to use that brush and paint their entire patient population with it. I find that that is a very easy thing to get caught in, but it's something I'm trying to be very mindful of when I speak to people. I like things to be very patient specific, and I don't like to cookie cutter people into one specific treatment modality. With that, be flexible. And by that, I mean, sometimes you need to take a left-hand turn during treatment, during surgery, or when you're restoring a case. Don't be afraid of that, right? That flexibility is what makes you great clinicians. The ability to think on your feet, the ability to think quickly and adjust to situations, that's what separates the wheat from the chaff. And on the lab side of things, when we're talking about restorative cases, I try to make our restorations solve today's problem, but plan for tomorrow's surprise. Too often, we think about solving the problem, but we're thinking in the very near term. We're thinking about it today. How do I get out of this? What's the patient's chief complaint, and how am I going to solve that? What I'm not looking at is what's going to happen 5 years, 10 years, 20 years down the road. Especially with implantology, these implants last a very long time. The restorations have the capability of lasting a very long time. And because of that, our work has to live with that patient for a very long time. And during that treatment, during their lifespan, so many things can change. As we age, our bodies change. And what was a great restoration for somebody in their mid-50s is not exactly the same applicable restoration for someone who's 75. And it's just something that we try to think about and how we're going to have our work today adapt tomorrow. And the last one, very simple, be honest and transparent. A lot of times we get caught into trying to please our patients at the sake of our restorative work. We see patients driving treatment more and more as their dental IQ raises, and it's a difficult proposition, especially in the moment. And I can say it, do as I say, not as I do, because I'm guilty of this as well. But we always have to strive to do what is clinically, driven with our patients. It's not the patient who's driving the bus. We still have to drive that bus. And I throw this in just because, this is a, very, quick visualization of that. And I tell people all the time, you can have it fast, cheap, or great. You can't have all three, so pick two, right? And that's what you can end up with. So it's something to always keep in mind. So when we talk about full arch, immediate load, I want to break it down to its core components, right? We have three main components to these cases when we talk about them. We have a surgical component. We have our multi-unit abutment and implant part selection, and then we have the prosthetic attachment, the conversion process, okay? Every one of these cases has three key fundamental stages, if you will, when we're doing this. Why do I bring this up? Because one of the best things about smart dentures is the flexibility of the system. And I'm going to keep going back to this. Tonight's overarching theme is going to be strength. And one of the key strengths outside of the physical properties of the system is the strength of this system to adapt to pretty much any situation that I can put myself in with these cases. When I look at my surgical and I look at my component selection and I look at my prosthetic attachments, so, these components of my day, my surgery, in that 3 to 4 hour window, well, actually 2 to 3 now, I have very clear guidelines for what I want to get done. And I don't want one of these categories influencing what I want to do in my other categories. So I'll get into that a little bit more, but I want to break it down for you this way because it's easier to understand. And the idea here is that we get caught in ecosystems all the time. All right. When we look at these products, one of the issues that we run into is this. When you talk about systems for full arch, right, people will talk to you about photogrammetry. They're going to talk to you about Chrome. They're going to talk to you about in sequence. You're going to hear all of these various products that are out in the marketplace today. Some of them are great products. Some of them absolutely will be perfect for the needs of your patient. Sometimes it won't. The ability for a company to keep you in an ecosystem is designed to control the dollars of a case. It's not there to clinically benefit you and your patient. So when we see these products in the marketplace, always keep an eye open and find out are they trying to do with this product? Are they trying to enhance my clinical experience? Are they trying to speed up my time? Or are they trying to make sure that I buy a guide, a restorative product, a kit, a final, whatever it is? All right. If all I see from them is saying, hey, if you buy this, we're going to give it to you cheaper if it's all at once, I kind of look at that and say, maybe that, the product may be great. It may be working in some situations, but I know that there's an ulterior motive going on there. Okay. So I don't want to be in an ecosystem. I don't like living in a sandbox. I want to make my own sandbox. And so when I look at these cases, my big thing is when I look at my surgical process, I know that on a given case, I'm going to have extractions, implant placement, grafting, and closure. Right? I want to determine the implants that I'm going to place based off of comfort level, bone type, and whatever's going on with the patient. It may be a case where we may be using some zygomatics. It may be a case where the patient has really dense bone and I can go with a non-aggressive thread pattern. It may be a situation where I need something that's very aggressive because we're trying to grab whatever we can. I don't want to be penned into one implant just because I'm using a specific solution. When it comes to the grafting and closure, that's not my bag. So I'm happy to do with whatever everyone else is happy to do with. Okay. But again, I want somebody to say, hey, we're using today's implant and this is what it is. And I'm going to just say, great. That sounds exciting for me. I don't want to have to go to a doctor and say, well, if you could use X, Y, and Z implant, that would be better for me. Component selection is another big one. Once we're done with the surgical, it's all about picking. The next stage is about us picking our multi-unit abutments. Am I planning for straight? Am I planning on using angled abutments? This way I can get optimal implant placement. I'm also thinking now about what is the position of these multi-unit abutments for the temporary versus the final. A lot of times, before I was using smart denture components, I would use a suboptimal placement of a multi-unit abutment because I was trying to protect the strength of my temporary or the aesthetics of my temporary. I don't have to do that as much anymore. I can put my access holes a lot closer. I can cheat a lot closer to an optimal final position with the latitude that smart denture conversions gives me. Okay. And it adds to the strength of the restoration, as we're going to talk about today. And I'm not going to steal Dr. Bender's thunder on that one, so we're going to keep moving along. And lastly, prosthetic attachment. Okay, this is where the chaos is. This is where everyone gets sweats in the middle of the night before the case. This is where people get cold feet, and this is where the horror stories happen. Too often, we're sold a bill of goods with different systems on, hey, this is going to be easy. This is the next greatest thing. Don't worry about it. You're going to love this. This is where clear, concise instruction and good repetitious, work pays off. This is where it is. These are where the cases are made and broken. A lot of times the surgery takes 45 minutes, an hour, hour and a half, and the prosthetic portion takes 4 hours. That's where we want to really help out everyone here. We want to give you peace of mind and let you know that the flexibility is here. Now, I've done traditional analog cases all the way to photogrammetry cases where I've been printing temporaries on the fly as we go. I am a fairly conservative person when it comes to treatment. And one of the things that I still always have in the back of my head is what is my plan if I have to bail out on this case? And how is this patient going to either benefit or suffer by the decisions that I make with this case? I like to have a full denture in my back pocket for these cases. I still do. And I'll tell you that a lot of times when I look at doctors who are doing this digitally with a stackable guide, with a surgical guide, freehand, whatever we see on the screen, there's often a very high percentage of the time where we look in the mouth and say, that's a little bit different. And I need to be able to have the flexibility to correct for situations on the fly. Now, if I have a fully guided situation and that is what I've decided that my goal is for the day, I'm kind of playing catch up with this case, and I am behind the eight ball. I may have to move screw access holes. I may have to be a little bit creative on how I pick up cylinders. I may have implants that don't torque out optimally, and we're really kind of crossing our fingers that they're going to integrate. Those are the situations that really give me sweats. But what doesn't give me a hard time is knowing that I have the flexibility to do whatever I want, or my surgeon has the ability to do whatever he or she wants. That's the important thing for me. I want the implants to go where the surgeon says, that's great. I want to be able to put the teeth where I say those are great. And that's the happy marriage that we can achieve with these cases. So from my standpoint, I don't really have a dog in the fight when it comes to how you want to put your implants in. If you want to put them in guided, great. You want to put them in freehand or semi-guided with a traditional guide, great. I'm just excited that they go in where you want them and they torque out. From my standpoint, once they do that, I need the prosthetic to be in occlusion, aesthetic, and I need it to be clinically acceptable for you and last that integration period. And that's where the challenge is. So when we start talking about all of this flexibility and everything else, and we start talking about all of these workflows that are out in the marketplace today, it starts to get a little crazy. You start talking to people and they tell you how they're getting from A to, let's call it Q, and it gets a little bit funky. So things get confusing very quickly. And what I want to show you with smart dentures is that it doesn't have to. We can have a really simple way of moving forward with these cases. There is, as we like to say, a smarter way to do this. So basically, you have four main steps that go into a smart denture case. Once the implants are in and your multi-unit abutments are selected, I'm going to create pickup wells, similar to what I do with a locator abutment. I'm going to seat my appliance in the mouth in occlusion. I'm going to make some adjustments for centric if I have to. I'm then going to trim my appliance down, removing flanges and pallets, create my access holes, and seat the restoration. That's really where we're at. And I want to show you exactly the magic part of this, or one of the magic parts. Once we've seated our restoration and we've picked it up, I'm going to pause this really quick so we can stop right here. I want you to take in the gravity of what I've done here. I've taken a denture. I've put it into the patient's mouth. I have cured acrylic in, and there are no holes in this appliance. I have locked this denture in. That should be like a moment of shock for half of you, saying, oh my God, I locked a denture in one time too. Worst day of my life. For me, this is the best day I could do, right? Because this is the magic of smart dentures right here. I have my denture, it's locked in, it's fully cured, and now I'm going to do something very exciting with it. I'm going to pop it right out of the patient's mouth. And I'm going to have all of my cylinders picked up very nicely, ready to go, ready for us to trim down. And that's one of the great aspects that we have right there. So I want to share with you a little bit of what we're doing clinically with these cases. And I'm going to give you a prosthetic case example, just a brief one, to talk to you about how we're doing this. Now, this case here was let's call it a freehand case. This was done based off of an immediate denture with a duplicate for a surgical guide. The implants happen to be BioHorizon in this case. And this doctor is a big fan of the BioHorizon Teeth Express treatment modality. So if anyone recognizes what's going on surgically, you can kind of put two and two together. So we have bone reduction that has happened in this case. You can see that all of our fixtures are slightly lingual to the existing sockets that we had in place. And we've gone ahead and we've put multi-unit abutments on. This was freehand, but they're using a clear surgical dupe of the denture in order to kind of line up angulation. And you can see that we have primary closure here on our implant sites. Next, we're going to put our smart denture components in place on the MUAs. Those white screws that you're seeing right there, if you're not familiar, are those magic breakaway screws that Dr. Kofford is going to explain in more detail. And on the right, you can see we're just blocking the denture out with a little bit of rubber dam. Here is my appliance seated in a basic centric occlusion. And what I'm doing is checking to make sure that I have a passive fit around those low profile copings that are in the mouth. And I just want to make sure that the majority of my occlusion is exactly where I want it to be, and it lines up with what's on the model. In this case, it does. Happy days. After I pick it up, okay, that's what you saw in the video. That was the same case. After we pick it up and I take it back out of the mouth, here's the fun part in the lab. You can actually put Dr. Kofford's analogs right on this case. They're included in your Smart Denture kit. I can pour a stone model and create a silicone matrix off of what's going on here. Why would I want to do that? Well, because as a laboratory, I'm always looking to save people time, energy, and steps in the chair. Now I have the patient's temporary, which has a verified fit. I have a master cast that I know is accurate. I have a vertical dimension available to me because I can simply articulate this appliance against an opposing. And the silicone dupe here allows me to replicate the appliance if I want to make an extra copy in the lab, or I can even scan it. Fantastic. So I've taken the first 2 to 3 steps out of your restorative appointments, and I've got them all done right here in what would probably take me around 15 minutes chairside. Once that's done, you can see here that we're drilling our access holes into the denture. So the way that this works, just briefly, before Dr. Kofford does a better explanation than I can do, is we're going to go from the bottom up. We're going to have a very slender pilot drill that's going to go through the intaglio surface and pop out the occlusion. Then I'm going to take a second drill from the occlusion down and just widen my hole. And then we have a third drill, which you see in the picture on the right, that is going to remove the little bit of the plastic screw head that gets left over. I will say that it's going to take a few cases to get this down pat, but once it's 3-4 cases in, I can do 6 implants in probably 7 or 8 minutes. It's that quick. It's that quick. It's that repetitive, and it's consistent. Coming back to the mouth, we're going to seat our appliance. And I love the screw access hole picture that we have right here. This is where it's at for me, because if you look, especially in the canine positions, I could never do this with a traditional pickup. I could never do it. The tooth would be blown out and I'd have a giant hole over there, and I'd be sweating, either trying to cold cure another tooth back on or tap dancing around this somehow. But with this, I don't have to worry about it. I can get these screw access holes right to the very incisal edge. And for the restoration in the temporary, it's more petite. In the final, it's an optimized position to ensure that I'm not having bulky restorations. And all around, it makes for a very, very easy seating process here. I don't have crazy angles all over the place, and I'm not trying to get screwdrivers in backwards. It really does calm the whole process down. It's very, very nice. And you can see here that we have this restoration seated. We have good adaptation to the tissue. I'm comfortable with where my occlusion is, really replicated what they had before. Great case all around. And then if you want to do a guided, go guided. Okay, here's another case that we did. This is our own printed surgical guides as well. You can see that we have a buckle carrier on here, and then we have the snap-in guides occlusally. So it's very, very flexible in this situation. You can go through and you can use any type of osteotomy guide you choose, place the implants, place your MUAs, and then here again, this goes to the flexibility and another strength of this system. Let's say that we use our surgical guide and 5 out of these 6 implants torque in at 50 Newton centimeters, and I get the distal one on the patient's left that torques in at 10. Well, I'm not happy about that, especially on a distal terminal unit. So If I was looking at this with a temporary that was printed and ready to be stacked on here, I'd be in trouble. I'd have to figure out if I'm going to move an implant, if I'm going to cut it off short, whatever. In this situation, I can just as easily move that implant distal, add another fixture, do whatever, because I'm still going to go back to a denture over the top. And because of the speed and the accuracy that Smart Denture gives me, I'm not losing time. I'm not losing the aesthetics. I'm not losing the strength and the function that I had. The system allows me to move quickly enough where it isn't a detriment for me to still have that denture and not have to worry about having a pre-made arch form temporary ready to go. So the flexibility is really there, and it allows you to do whatever you wish. Now, if you wanted to do a stackable and you absolutely wanted to do that, I can still use Smart Denture components to make the aesthetics of that final product much better than what it is. But I'll tell you this. I've done a lot of stackable cases. I've done a lot more traditional cases. And one thing that I will tell you is that if I take a stackable restoration and I take what I can do with a denture, I'm going to pick what I can do with the denture. Number one, I am a little biased because I have my own two hands, but I'm also able to better reline that temporary to the tissue. And I'm also better able to control my screw access holes and the overall aesthetic rendition of the temporary better with the denture than I am with an arch form temporary. So I think that, for me, I don't like to be hemmed into one solution, and this gives me the ability to really broaden my horizons and do whatever I want with the case. And I'll just say this briefly. So we have our 2-day course coming up in October, and that's going to be a great course. We have a 2-day course. You're going to be able to restore 6 arches using Smart Denture components. Dr. Kofford is very, very adamant about training. So I will caution you, if you've been to any boot camps, they're nothing like what you're going to do here. He's going to give you the business. So, but the tuition for this course includes 4 team members. We really strongly encourage team members to come here because that is what makes the magic happen, right? This isn't a one-person event. This is for you and your team. And as another exciting option for this, when you do sign up for the course, you get a free starter kit from Lexier, and you also get $1,000 off your first full arch case as well. And additionally, you get 16 CE credits, which is pretty much half the year. So that's great. So with that, I want to turn it over to my good friend, Dr. Brandon Kofford, and I'm going to stop sharing my screen right now and let him take over. But I'm happy to answer questions. I'm happy to duke it out from a clinical philosophy standpoint, whatever we need. So thank you all very, very much.
Ryan, that was awesome, and I don't know that there's anything left for me to talk about. That was amazing.
Oh, there's always more. Come on.
So let's see here. I'm trying to gain control of the screen. All right, yeah, we're just gonna go to this one right here. That was awesome, and that was a really great summary of the procedure. Is my screen coming through okay, everybody? Awesome. So this is just a little bit about my background. Of all the accomplishments and accolades, I'm really most proud to just be called father. I have 6 children. As far as my professional accomplishments, if you look under honors, awards, and achievements, that says the Pucker Award, the 2011 Pucker Award. So that is an award that was given specifically to me by my training instructors in residency because I almost cut my fingers off with a disc, and it startled me so much and so I was given the Pucker Award for my laboratory ineptitude. So just to give you a background as to why I would be searching for the easiest way to do anything, it's because of that award as just having laboratory ineptitude. And I think my presentation shows that a little bit. But the things that we always talk about when it comes to smart denture conversions is it's faster, it's stronger, and it leads to just a better prosthesis, a temporary prosthesis. Well, what's the value of having a better prosthesis, a better temporary prosthesis, or a stronger temporary prosthesis, or getting it done faster? Well, faster is obvious, right? Everybody wants to go home to their 6 children, I assume. And then everybody wants it to be stronger because it's less likely to break. And the last thing that I want to deal with is a broken prosthesis that's going to occupy my chair time and add stress to the schedule and just make for not a very fun day. So I don't want my temporary prostheses breaking on me. And if I make a better provisional prosthesis, then getting to the final becomes so much more predictable. And I love predictability. The last thing I want to do is go back and forth and back and forth and back and forth, just trying to work out the aesthetics, finally getting to something where the patient's like, okay, if that's the best you can do, right? They they lose their confidence in our abilities if we can't deliver a nice provisional. Yeah, we might say, well, it's just a temporary. Here in 3 months, we'll fix it. We'll make it better. Well, no, I want to gain my patient's trust and confidence right from the get-go because it makes everything smoother on the subsequent appointments. So, in addition to faster, better, stronger, this does lead to a reduced cost overall for treatment. The simplicity, it is so much easier for me to do full arch fix now, to the point where we don't even really have to think about them. It's just super easy because it's just like a locator pickup. The predictable outcomes, the faster chair time, the stronger prosthesis. Dr. Bender, I'll introduce a little bit later, but he's going to present to us his master's research that demonstrates how a smart denture conversion does in fact lead to a stronger prosthesis. So when I set out to do this, I did not think that I was making something that I would be ever introducing to anybody else. I thought I was just making something for my clinic. And I was just building on a restorative technique that I already knew very well. A locator pickup, super easy. I never stress about doing a chairside overdenture pickup. Easiest thing to see in the schedule. And I needed something that was simple enough that even my surgeons could do it in case like I couldn't get to surgery, they'd be able to take over for me. And I needed something that was going to take me less time because I was spending 3 hours doing these miserable conversions. And granted, laboratory ineptitude, I grant you that. But I needed something faster. So I developed this system thinking that I was just doing it for my practice. But it turned out to be something that a lot more people were interested in. And so that's why we have a webinar tonight. But so this technique, this chairside overdenture pickup, it's so very well understood and it can be delegated to our staff. So this is what I was looking to duplicate for my fixed protocol. And it was all made possible by the invention of this separable fastener. This was a concept I conceived while I was in the throes of a very miserable denture conversion on 6 implants in the mandibular arch on a patient who was partially sedate because it was oral sedation, and she was just very difficult to work on. And I just thought, oh, this would be so much easier if it was just like a locator pickup. And I thought through that process, well, why can't it be just like a locator pickup? And I thought through that, well, a screw is holding the temp cylinder down to the multi-unit abutment, and it's the head of the screw on the inside of that temp cylinder that's clamping it down. So I thought, well, what if I made the head of the screw separate from the threads of the screw? Then I wouldn't have to maintain access to the screw and I could treat it just like a locator pickup. And so I was introduced to a patient who had a prototyping business, and I said, oh my gosh, can you help me with this? And I just So he and I, the system, which is built on this technology, the separable fastener, this is our secret sauce. So like if I were to break this down, a very basic workflow, you have a denture. So you get your components on your multi-unit abutments. You make the wells in the denture that give you passivity over those components. And then you fill the wells with acrylic. Then you snap the denture away. And then you contour that denture to the ideal contours. And then you deliver it back to the patient. So this is what the pickup procedure looks like. And I love showing this because you can see that mandibular arch is held in the ideal position or ideal occlusion against the maxillary arch. You can see that we're going to guide the patient in centric relation down into that intaglio of the prosthesis. And I'm just going to let that set. Doing it this way, I know for a fact when I come back to deliver it, I will have the perfect occlusion. I will not have to adjust the occlusion at all. That's a big win for me because now I'm preserving the aesthetic surfaces of the teeth, the functional surfaces of the teeth that I can duplicate later, like Ryan showed. I love that you showed that, Ryan, where at the time of surgery, you can make all of these records and have a prototype if you needed to improve on something, or just an exact duplicate of it to verify that you were ready to go to final. And you can have that ready for your 3-month recall where you're going to be making whatever records you need to make. It's just awesome. So now, like Ryan showed you, you can just snap the denture away, and it's all because of the separating action of the head of that screw from the threads. Well, now you might be wondering, well, now I've broken this screw into 2 parts. One part is stuck in the multi-unit abutment, and one part is stuck in the tie base that was picked up into the denture. And you're right, we did separate it into 2 parts, but it's not broken. The way it separates allows us to easily retrieve that fragment. Here you see our retrieval tool that fits into a lab handpiece. I'm sorry, an implant handpiece or a contra angle slow speed. And you just put that in reverse and back the thread component right out of the multi-unit abutment. Super easy. So this is what that looks like. Whoops. Well, yeah, so here I'm using my contra angle handpiece. Just slip right down over that fragment and it'll back right out. All right, so then after you've contoured it in the laboratory, and that should take no more than 15 minutes to cut your flanges, cut your palate, rough cut it, start polishing it, and maybe add back a little into the intaglio. It should not take more than 15 minutes. If it's taking you longer than 15 minutes to do that, you need to reach out to me, and I will talk you through what handpiece you should be using, what burrs you should be using, and the sequence to do it. We go over this ad nauseum in our training course that Ryan talked about, but it should not take you more than 15 minutes to contour that prosthesis. Now that it's contoured, you can easily create the screw channel in a 3-step process. The first step is going through the intaglio with a pilot drill, and then coming down that pilot hole with an access drill. We call it an access drill. It's really just a counterbore drill. It's going to take that all the way down and bottom out on the top of the tie base and create a pathway for us to now retrieve that fragment out of the inside of the tie base. And we do that by hand with an instrument called a pin vise tool. Here you see me doing it by hand. And then once you've created the freedom of that fragment to come out, you can just take your pilot drill and push it right out. And it went fast, but there was the head of that separable fastener was right on that pilot tip, and it just popped right off. All right. What Ryan was saying, I cannot overemphasize the importance of being able to select our multi-unit abutments for their optimal position in the final restoration, as opposed to trying to optimize by paralleling the temp cylinders for the provisional prosthesis. The separable fastener accommodates 70 degrees of divergence, which means you should be selecting your multi-unit abutments so that your screw channel comes through the occlusal table of the posteriors and the cingulum of your anteriors, period. That is what you should be shooting for. And when you nail that, your contours for your prosthesis are way better. And that's what we're going to be talking about in our next webinar, is how to significantly improve your intaglio contours and your occlusion by using separable fastener technology. All right. So Ryan did a good job of showing this actually better than this. So the concept is, here we've got the parts or the multi-unit abutments in place. So, the tie bases and separable fasteners going onto the multi-unit abutments. You might suture up, and then here I blocked out with some cool dam. I prefer using silicone dam now. This was early on. This is a case we published in the Journal of Prosthodontics. So that's why I keep it in here. It's just kind of a legacy case, but I prefer using silicone dam. And then you do your pickup. There's that fragment that remains. There's the fragment inside the tie base. And you can see there's no screw channel yet. So just do that pilot hole, then you do that counterbore hole, and then go after it with that pin vise tool. Once you've got that fragment out, this is just a screw-attained prosthesis. But you can see how much better the occlusion is. You can see how much better the strength of this prosthesis would be, because we don't have large access holes that were then just filled back with cold cure acrylic. That's where the strength comes from. I would like to mention just a little bit, and Ryan, if you don't mind chiming in, I really love converting monolithic prostheses. Ryan, does Lexer offer that to your customers?
We do. We do. And you know what? As the technology and the aesthetics have improved, it's becoming one of my go-tos as well. These solid monolithic temporaries are, the last thing that I want to see in the schedule, or you want to see, is, temporary broken tooth popped off.
Right. Oh my gosh, exactly. So, and Dr. Bender is going to be presenting to us his research, which was comparing not just the conversion technique, but also the materials used for the conversion technique. So the strength is going to be a function of how it was converted and also what was converted. This is a very important, this is my soapbox. Contours matter. For these to be long-term prosthetics for our patients, predictably long-term prostheses, we need to make them hygienic. We need to make it so that a patient can keep it clean. So hygienic means I can drag floss from one implant to the next implant, and that floss maintains contact with the entire intaglio surface, the entire length of from implant to implant. That is our responsibility as clinicians. And if you're struggling with establishing these contours and you'd like to learn how to do it, please consider coming to a course. We can get this figured out for you, no problem. And then you deliver the prosthesis and it goes down perfectly passively. There's no occlusal adjustments needed. And it's just super predictable. I love these. I love these cases. They're awesome. My experience, because of the separable fastener, I've been getting much better results. It's a lot faster in the procedure of the conversion itself, but also because we're making a stronger prosthesis that's not fracturing all the time. We're spending less time with the patient. We're also making a better prosthesis that serves as a template for the final, so the whole treatment is faster. This is more predictable because of all these. It's less stressful, which makes me happier. It makes my surgeons happier because I'm getting it done. I was in a zygoma case yesterday. The surgery took, I think, 3 hours. I was done with the prosthesis in less than an hour. And I tried putting the pictures into this presentation as Ryan was talking. I just didn't have the time to do it, but we'll include it in the next one. Getting those screw channels just right into the occlusal table of the posteriors and the cingulum of the anteriors, it just makes all of us happier. My staff, because I'm less stressed and the outcomes are better and the more predictable. My staff doesn't dread these days and these procedures. So they're a lot happy to recommend this treatment, which is what patients, patients don't really listen to what I say and my recommendations. As soon as I leave the room, they're turning to somebody and they're saying, what do you really think? And if they don't believe in the treatment because it's a pain in the butt, then that's going to show. So having a more predictable and an easier process for my patient and my staff makes it for them to really put their heart into their endorsement of the treatment. And ultimately, my patients are happier. That being said, next time we're going to talk about better. This is my contact information. Please reach out if you have any questions whatsoever. I really recommend don't even bother with my email address. I am terrible about email. Just text me and I'll be happy to respond to any questions that you might have. Now, let me introduce you to Dr. Bender. Dr. Bender and I met in Nicaragua. What was that? Was that 2 years ago?
Yep, that was 2 years ago, 2021.
May 2021, right? So we met in Nicaragua when Dr. Bender was doing a full arch course, and I was there for my first time as a vendor of smart denture conversions. And he, as a pros resident, totally saw the value of what I was teaching. And he said, I want to be a part of this. So I said, well, I would love for you to be a part of this. I need somebody to do a research project on my claims that this is stronger. I know in my practice, I have a lot fewer fractures than I had before. So I can make that claim, but I need somebody to do the research to prove it. And Dr. Bender said, I'm your man. So Dr. Bender, why don't you go ahead and take over?
Yeah, sure, absolutely. Let me see if I can share my screen, and I'll pull up my presentation as well. Bear with me, everybody. Okay. Okay, let me know if everyone can see that slide and hear me. Yep, good. Okay. So I'm Dr. John Bender. I'm a prosthodontist, but I like to say I'm a surgical prosthodontist as well. My favorite thing to do is to change my patient's life, and a full arch implant therapy, when indicated, when with failing dentition, certainly is one of the biggest things a dentist can do. I was lucky enough to be in a residency, a pros residency, where we did the surgeries. So we were the surgeons and prosthodontists doing the denture conversion and the hybrid after. And being in the pros program, I was really good at the pros, but the surgery, I wanted to be faster and better at it, which is why I went to that full arch course where I met Dr. Kofford, and that's how it all got started. I want to just change to this next slide just to kind of really show everybody watching just the difference between smart denture conversion and traditional conversion. As I kind of talk about this, there really isn't a comparison. The top is the traditional conversion, and the bottom is the smart denture conversion. And I was excited to go to Nicaragua because I already knew half of it. I already knew the traditional conversion. I was already a year into pros. And lo and behold, when I got there, I found out I was going to be learning two new things. I was going to be learning the surgery, which I was there for. But instead of doing it the way I was taught, the traditional, we were going to do it the smart way, the smart denture conversion. And it didn't really take long at all for me to realize, wow, this smart denture conversion is without a doubt the way smarter and better way to do it. It's much faster, it's much stronger, it's more efficient, it's easier. And I love how Ryan and Dr. Kofford were saying it's really similar to an overdenture pickup. An overdenture pickup is really not hard. And what smart denture conversion does is it takes a fixed traditional conversion and it simplifies it to the level of a overdenture pickup. And that's one of the best parts about it. As you can see in the diagram, the top traditional conversion, you're boring out and mutilating the denture for the only purpose of accommodating the long temporary cylinder and destroying the aesthetics. mutilating the denture, causing cracks and craze lines. Even though you fill in those cracks and those holes, you just bore it out. There are microfractures and cracks inside the denture, and those cracks can spread and lead to a fracture during the healing period. If that happens during the implant healing period, you may lose implants. That's a really big problem. As you can see on the bottom illustration, there's no mutilation of the denture base. In fact, actually, the only hole is a 2.5 millimeter prosthetic screw channel. And as you can see, you would think with common sense, you would say, well, clearly smart denture conversion is stronger, obviously, smaller holes, so more structural integrity. But I jumped on the opportunity to prove it scientifically. So let me show you my research.
Those top pictures do give me a touch of PTSD, I'll tell you that.
No, it's funny you mentioned that, because I came back from Nicaragua and all the conversions I did were smart denture conversion, and all of my co-residents didn't know about it or didn't believe me, or didn't hear about it yet, because when I met Dr. Kofford and learned about that, he had just invented it. So I'm doing a conversion in 30 minutes, 45 minutes, and my co-residents are doing it for 3 to 4 hours. I'm leaving in the early afternoon, and they're still there with the professor, and my faculty are confused. They're just looking at me like, how is this kid finishing his full arch conversion in under an hour, and the other kids are still in the clinic for the whole day? So the last thing I had to do was, let's prove it scientifically, because one thing about being a specialist is it has to be evidence-based. If it's not evidence-based, then it's not going to be accepted by everyone. And luckily, this is now evidence-based. So obviously, one of the most concerns about in clinical dentistry is fracture strength, whether you're doing it definitive or temporary. If it fractures easily, you don't want to do it. When it comes to dentures, there's many materials. Commonly, there was injection molding PMMA dentures. There is monolithic milled PMMA dentures. Avident has a great product. You can even 3D print dentures, and one of the materials for 3D printed dentures in my product, I use the Onyx Tough. So not just the Onyx, but the newest version Tough. And those are 3 ways that we see dentures nowadays. And of course, there's the traditional heat process dentures, but those 3 are more superior, and I'm sure they're more common out in the field. So what was my research about? Kind of being scientific now, I got to put on my scientist hat. The specific aim of my master's research was, I wanted to test my hypothesis that the novel technique, the smart denture conversion, produces a stronger prosthesis than the traditional denture conversion technique. And then secondly, I just went over 3 materials that are used for dentures. I also wanted to see if the material of choice influenced fracture strength as well. So here's my design overview. What I did was, we went all out to make it super legit project. I made 180 specimens total, between 3D printed, injection molding PMMA, and milled PMMA. So there were 60 samples per material. All the samples looked like that, with the same common height, width, and length. Just switching my screen here. Okay. And if there were 60 specimens per material, that means that there'd be 30 milled with holes in them for traditional, and then 30 milled without any holes for smart denture. Same thing with the 3D printed, and same thing with the injection. And just to emphasize, so 180 samples, 90 of them we did a traditional conversion, 90 we did a smart denture conversion. With the 90 traditional, whatever the material was, you had to mutilate the specimen or the denture. You had to drill out those 8 millimeter diameter to accommodate the temporary cylinder. Here is the specimens or the dentures that we did smart denture conversion. Noticed how they're not mutilated at all. We didn't drill into them at all. They're just like an overdenture pickup. And with the smart denture conversion, you see on the right side is the short tie base. That's why you don't have to drill any holes into these dentures when you're doing smart denture conversion, because the tie base is so short. It's only 5 millimeters versus a long temporary cylinder. Once I made all the specimens, and I'll show them made in a second, we took them to an Instron machine, a very fancy scientific testing machine, and with a computer attached to it, and I loaded them to fracture, and I recorded the specimens to see how strong were they. So here is how I did the smart denture conversion pickups, and this is a refresher. So if you're watching this and you want to see one more time how to do smart denture conversion, listen and pay attention right now. We have two replicas that simulate multi-unit abutments. So the multi-unit abutments are in the mouth attached to the implants. All you do is you take the short tie base and Dr. Kofford's separable fastener screw, and you screw the tie base into the multi-unit abutment with the separable fastener. And I used general purpose acrylic resin powder and monomer. Just I mixed powder and monomer together like you would do any pickup. And I injected the powder and monomer into my specimen or the denture. And I injected the powder and monomer around the tie bases as you would in the mouth for a real clinical case. Put the smart denture conversion specimens on top of the tie bases without any holes because they're short tie bases. And once it sets, you just snap the specimen or the denture off of the tie bases and the multi-unit abutments with very little force. It takes relatively very little force to snap it off. And as you see, every single time I've done this clinically on full arches, and I've done this 90 times in my research. Every single time, whether you have 2 tie bases like this, whether you have 4 for an all-on-4, whether you have 6 or 8 or 10 multi-units, every single time I've done it, the cylinder picks up perfectly. And that doesn't happen with the long temporary cylinder where you have to go back, oh, it didn't pick up or it moved, and you got to re-pick it up. Every time it gets picked up, and that's due to it being so short and the 90-degree divergence accommodation that Dr. Kofford talked about.
70 degrees.
Sorry, 70 degrees. Still amazing. So then, okay, it's picked up. The tie bases are there. Amazing. But now this is a screw retained prosthesis, this is a screw retained denture. How are you screwing it into the implants? Well, it's very, very simple. There's smart denture conversion has 3 really easy drills. The pilot drill right through, I'll go back a second. The pilot drill right through the tie base. So for a pilot hole, the second drill in the middle is the enlarges the channel for a prosthetic screw. And the last drill is very important. You have to manually go through, clear any debris, and it picks up the peak head. That way you have a nice channel. And I did this 90 times, and it was no problem. And it was much faster, much easier than the 90 that I'm about to show you, the next 90. So now it's time to make my 90 samples for the traditional conversion, so I can break them and see which one's stronger, smart denture or traditional. So just like you all know, everyone here who's done the conversion, you have your multi-unit abutments. In this case, it's a block with lab analogs. I screw in the long temporary cylinders. I inject around, and my sample is in this slide now. My sample has the 8 millimeter bored out screw holes or axis hole. Otherwise, you can't see the denture because the temporary cylinder is so long. You can't see the denture in without mutilating the denture and drilling those holes in it. I injected the acrylic into the specimen or the denture. I injected around the temporary cylinder. Of course, you would plug those temporary cylinders with a wooden stick or some kind of silicone or Teflon tape, which you don't have to worry about with the smart denture conversion technique. They stick through, and because they're sticking through, you can't pick this traditional denture conversion up in the mouth in occlusion and save a lot of time. It sets. You unscrew the screws from the temporary cylinders and you take out the specimens. It's picked up. It's not a problem. It's only 2. With more implants, it's a problem. If you've done it, you would know. And this is what it looks like. And you can see you have pickup material filling in the big holes and your cylinders poking out through and through. And even though this is a specimen, it doesn't look as neat as my smart denture conversion ones with the little tiny screw axis holes. This was group 1, so I did this for all the materials. Again, 3D printed Onyx resin. This is the traditional. Notice the big holes. And you also have to trim back the temporary cylinders, which sometimes heats them up and makes them move. You got to pick them up again. This is versus 3D printed smart denture conversion, much smaller hole. Group 3, milled Avident, traditional conversion, large holes, pick up material, trim back the temporary cylinder, versus milled smart denture conversion, clean. Group 5, injection molded PMMA, traditional conversion, versus injection molding smart denture conversion. And what I did was, once I had all 180 samples and they all screwed down onto my jig, I loaded them with an Instron machine. And I looked at the average values, what's the strength of each of them, of each of the 180, and you got to also put the averages out. And here are the results. And this was completed in an engineering lab with mechanical engineers with me there. The statistics were completed by a statistician in my university, Nova Southeastern University, with me there. So this is a completely legitimate research project with 180 samples. And I try to be like Dr. Kofford. He published his article, his research in the Journal of Prosthetic Dentistry, a very highly respected PROS journal. I'm in the process of publishing my results, but let's look at the results. 3D printed, okay, conventional versus smart denture conversion. The mean flexural strength, the fracture strength, smart denture conversion 3D printed, mean was 79.23 versus the mean of the conventional 67.41. So if you have a 3D printed denture, smart denture conversion is a stronger prosthesis. Injection PMMA, mean fractional strength in megapascals, 68.50. Mean for the conventional, 54.4. Smart denture conversion is stronger for the injection PMMA. Now, this is just a lab study and it's a partial segment, and it's not a full large denture. When it came to the Avident mill, it was very close to the conventional, but due to limitations of a benchtop study, the conventional conversion, the mean came out to be a little bit higher than the smart denture conversion. But that's okay, because most of the samples in that study were stronger. We just had a couple samples break really early, and that brought down the mean. So if this was done again under a more precise research, you would obviously see that the smart denture conversion is stronger. However, due to all of these numbers and reviewed by the statistician, we were able to confidently say that the method of conversion, the smart denture conversion, is statistically significantly stronger than traditional denture conversion. So the method of conversion was stronger, the material of choice was stronger, being 3D printed being the strongest. And then if you combined material and method of conversion, it was also statistically significant. And I have proof of this. If you go back into your statistics class that we all took in high school and college, you know that your p-value has to be less than 0.05 to be statistically significant. And you can see that for the method of conversion, the material and the method of conversion times material was all less than 0.05. Here is a diagram just showing how smart denture conversion is stronger than traditional denture conversion prostheses. And here is another slide of even more data scientific research. And I want to point out this. So out of the 180 specimens, the lowest fracture, meaning the weakest specimen of the 180, was one made from injection PMMA made, of course, from traditional conversion. It broke at 19.4 megapascals, really low strength, versus the highest of the 180 specimens that fractured was from group 2, the 3D printed material converted with smart denture conversion with 120 megapascals. And I just will show you the fracture patterns of a lot of the samples. Again, clearly it's not hard. How do you know which one's smart denture, which one is traditional conversion? Look at the aesthetics. Look at the aesthetics. When you do a conversion with smart denture conversion, it looks like a final restoration. This is a small axis channel. There's no mutilation. This is a smart denture conversion specimen. This is another smart denture conversion specimen. This one, the shell cracked off. And I just want to point out that in the discussion of my thesis, the 3D printed dentures converted with smart denture conversion had the highest mean flexural strength, as well as the highest individual flexural strength. Smart denture conversion for the two materials for the mean was strongest, even though for the Avident milled it was not, but that's okay because most of them were. There was just a few samples that brought the mean value down. You know, it's a lab study. I'm a dentist. I'm not an actual, scientist. But here is an amazing statistic that we found. 3D printed material, smart denture conversion, was 31% higher fracture strength than injection molding traditional conversion, a traditionally converted sample. And why is smart denture conversion statistically significant in making a stronger prosthesis no matter what material? It's because of the destructive step in the traditional conversion technique. To accommodate the long temporary cylinders, you have to bore out a huge hole into your denture, which is obviously going to weaken your dentures, your temporary dentures, and which obviously weaken these specimens. Conclusion: smart denture conversion technique does significantly increase flexural strength of all materials. And someone who did 180 samples, the 90 I did with smart denture conversion versus the 90 I did with traditional denture conversion, the smart denture conversion was way faster, way easier, and they were way stronger. And here's my references for my research thesis. And that's it. I'm gonna let go of my screen so we can continue the presentation. And as I do that, just to say, once I learned the smart denture conversion technique, there's no going back. So if you want something faster, something stronger, something more aesthetic, there's no other way to do it. And I highly recommend you give it a chance. And you need to practice. You need to do a couple practices. And once you do, you will see the same view that we all see. And you'll reap the benefits. Okay.
Dr. Bender, thank you so much for presenting the results of your master's project. That was a pretty incredible project as far as the way you organized it and all the samples that you put together. Way to go.
Thank you.
Yeah, absolutely. Yeah, and it was interesting to see that the printed material fared the best. If you asked me my knee-jerk reaction, I would have put milled materials at the top of the list. So that's interesting for me too.
Yeah. I would say now the milled materials would have come out more if those couple samples didn't break so quickly and bring that value down. But this is actually one of the newest resins that came out on the market. So look out for these newer resins. They're monolithic. When it's 3D printed, it's monolithic. So look out for these newer resins. I saw really strong, even when I was drilling the holes, and I was drilling the holes versus Avident and the 3D printed, it was harder to drill the holes for the 3D printed. So I attribute that because it's a newest generation resin. I'm just
Yeah.
trying to actually figure out for a second. Sorry here. How do I stop sharing my screen? Oh, I see it here. Stop sharing.
Yep, there you go. Yeah, it's the resins are moving so quickly nowadays that I mean it's tough to keep up. But that was really interesting to see. So thank you for sharing that. That was wonderful.
Yes, absolutely. My pleasure.
Yep. So, all right. Well, that brings us to the end of our adventure this evening. So thank you, Dr. Bender. Thank you, Dr. Kofford. And if anyone has any questions, we can go ahead and I think we can unmute everybody. I'm going to leave that to Sarah. Let's see if she can do it. And yes, I want to leave you with education, education, education. We do have our next upcoming webinar, which will be the third part of our series. In addition to that, as I said, in October, we do have our 2-day hands-on course in North Carolina. Looking forward to seeing everyone on that attendance list as well. That's going to be a great course. I'm really looking forward to that. So let's see if we can get people off mute. Maybe yes, maybe no. If you can't unmute, go ahead and use the chat. There we go. Looks like we can. All right. So looks like we are fairly good on questions and a few minutes over on our time. I'm sure everyone has places to get to. So I thank you all very much for your time tonight. And again, if you have any questions, feel free to reach out to myself, Dr. Kofford, on his cell, not the email, and we'll take it from there. All right. So thank you all very much. We really appreciate you coming out tonight. Hope to see everyone in a live event pretty soon. Take care.
Hey, and Ryan, I just want to thank you for organizing these things, just putting out this real high quality content for elevating all of our practice in full arch fix. So just thank you for everything you're doing to contribute to the body of knowledge out there.
There you go. Thank you very much. All right. Have a wonderful evening, everyone. Take care.